Alright, so on this presentation, I'm gonna work on the decision support system for a financial institution using a binary tree assignment. And it's basically a algorithm that's gonna measure the depth of a binary tree for a financial company that's gonna ask its users a series of questions, basically a yes and no. And while I was reading the assignment, I thought of some questions about it, such as like, what if a customer said maybe, and um, you know, what if there was some data that needed to be input, or why not? But for simplicity, I'm gonna keep it with yes and no. um, I'm gonna do the left side of the binary tree as a yes, for because it's intuitive, and the right side's gonna be a no. All right, and as you can see, I started with so you can see on this repo, I have the decision support DSS, and I'm gonna start with the first file, which is gonna be binary tree.py. This is where gonna be the we're gonna have the binary tree.py algorithm. We're gonna start with the class. We're gonna name it tree node, and this is basically the bone structure of the algorithm. And this is gonna represent, it's gonna represent a node in the decision represents a node in the decision support binary tree. We're gonna define it. Define initiated. We're gonna initiate the class with self and question, and then we're gonna start with self question equal question, and this is gonna be the question itself. And then we're gonna have a self that yes as a child. We're gonna initiate it with none, so empty. Then a self that no equal none. Now we're gonna define the function that's gonna calculate the max depth. and it's gonna pass a root. And then first thing that we wanna make sure it's clear, so if not root, so if the tree is empty, return 0. Otherwise, length depth equals max depth of root that yes. In the case that, you know, most questions, all questions were answered as yes on the left side of the tree, or it has the option of max depth of root no. And then we're gonna return, it's gonna return 1 plus, because it's counting the 1 because it's already assuming the root node plus the max left. We're gonna use this max to figure out whether the left depth or the right depth is a maximum. So if there's no root, it's gonna return 0. And then if left depth is a maximum, we're gonna figure out by this max function, and then after we write this basic binary tree.py, we need to start with the testing. So test that binary tree.py. Okay, so the first we need to import unit test, and then from binary tree we need to import tree node and max depth. We're gonna start with the class test binary tree, and then unit test dot test case. We're gonna define test normal case, which is gonna pass self, and then for the root question, we're gonna pass it as a tree node, and then the first question is gonna be, are you interested in loans? I'm just copy and pasting, so this is gonna be like the basic one. So yes, if the person responds yes, Then the second question um, should be, do you have a high credit score? And going back to the initial questions that I was raising, this one was one of the parts that I thought could be a maybe, or because a yes and no is a close-ended question, and also the in a more complex and um, user-friendly algorithm, it would ideally ask for the um, score range, and depending on that would like offer different loans. But for simplicity, we're keeping it to a yes and no response. And then if this is the left side of the tree, and if the person says no, um, we can ask, are you looking for short term financial help? And then going back to the left side, yes, that yes. Um, we're gonna say that you qualify for a premium loan. So you qualify for a premium loan, um, assuming that the person said yes, that they have a high credit score. And if the answer was yes and then no, uh, it will say you qualify for a standard loan, based that the person doesn't have a high credit score. And then finally we have the no, no, and leave, because this is gonna be the end of the binary tree on the right side. It's gonna say consider financial counseling. And then we're gonna solve that assert equal max depth. We're gonna pass a root. So this number, the return number of the max depth after passing the binary tree, should be 3. It's maximum, right? As we can see here. And then we can start with the defining the test edge cases. We have self and the alright, so first one that we need to do is a single node. We need to pass tree node, only one question. So we're passing only one question, and we're gonna self-assert equal root 2 1. We're gonna assert equal root to 1 since we have only one question, right? On this specific case. This is gonna be number 1. Single node tree. And then for the next one, we have number 2, which is gonna be the left skewed tree. We're gonna say left. We're gonna name it left skewed. It's gonna have tree node. We're gonna have this start as its root, and then left skewed yes. We're gonna have question 1, and then left skewed yes dot yes. We're gonna have question 2, and then left skewed yes yes yes. This is gonna be the final. It's just gonna be the leaf, and it's gonna be question 3. And then we're gonna self-assert equal max depth of the left skewed tree, and it should be 4. And then for the final third edge case, we're gonna do an empty tree, and then we're gonna self-assert equal max depth to none. So it's a tree without any nodes. Should be 0. And then if name equals to main, as a unit test that main. Okay, and then we're gonna run in the terminal test binary tree after I saved it, and it's okay. So as we can see, it passed the tests, and this is a showcases that the maximum depth, meaning the maximum questions a questioner is gonna have for the given financial help software. Alright, and then for the diagram, that I'm gonna explain. I'm gonna open a new window. I'm gonna open my lucid chart. And then gonna copy and paste a sample. And then as you can see, here, it starts and inputs first customer question, evaluates whether yes or no, and if it says yes, it goes on the left side of the tree, and it goes to the next questions, controls until the final questions, recommend final product, and end of decision. And then it would do the same for the other side with no, 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 and then with the counting algorithm, it would iterate through the questions and see what the maximum depth would be. Um, this finalizes my presentation. Thank you.